Have you ever felt that sheer frustration when your computer just doesn't do what you want? I mean, we've built these incredible machines, but modern graphical interfaces kind of just reduce us to animals pushing colorful levers for a treat. There's this brilliant quote that hits the nail on the head. We get the chimpanzee hitting buttons, but we chat with each other. It isn't as good. Think about that for a second. We're wired for deep, nuanced language, right? But we constantly trade all that expressive power just for the convenience of clicking a shiny button.
And that brings up a massive conflict in how we compute today. On one side, you've got the modern web browser. It is incredibly fragile. Your internet flickers for literally a millisecond. An API drops, the page refreshes, and poof, hours of work gone. But contrast that fragility against the unbreakable pseudo-terminal or PTY channels. These give us a lossless, mathematically certain text pipeline. It's completely isolated, it's secure. We're talking about a fundamental shift from just crossing our fingers and guessing to absolute deterministic exactness.
So welcome to the Explainer. Today we're zeroing in on the unbreakable text stream, specifically looking at GNU screen and PTY. We're going to explore how to finally move past those heavy, breakable graphical interfaces and build unbreakable context loops for modern AI agents using pure text pipelines that guarantee absolutely zero data loss.
Okay, here's our roadmap for today. We'll start with 1, the graphical dead end. Then 2, the semiotic bridge. 3, mechanics of PTY pipelines. 4, the historical text stream. And finally, 5, sovereign AI swarm orchestration. Let's dive right in.
Section 1, the graphical dead end.
So, graphical user interfaces, GUIs, they are just incredibly heavy. They chew through massive amounts of computational power just to render things like drop shadows and rounded corners. And what happens when we try to get AI to automate tasks on these graphical systems? Well, we're forced into these super fragile, hacky workarounds like screen scraping. The AI essentially has to take a messy, pixelated picture of your screen and literally guess what to click based on shapes. If a website changes its layout even a fraction of an inch, the entire automation just instantly breaks. It's an invasive, error-prone mess.
Section 2, the semiotic bridge.
This brings us to a really crucial paradigm shift, the semiotic bridge. It's this beautiful idea that text serves as our universal deterministic interface. Think of it like a highly secure translation layer. It safely compiles our fuzzy, messy, associative human imagination directly into the rigid, exact mathematics of the computer's arithmetic logic unit, or ALU. It completely bypasses all that bloated graphical guesswork we were just talking about. Imagine it like a giant funnel. Up at the top, you have our messy human intent. We take that intent and squeeze it into the rigid, monospace cellular matrix of the command line interface. From there, the text gets lowered into a geometric tile, which is basically an intermediate representation for modern processors. And finally, it hits pure ALU hardware execution at the bottom. At every single step down this funnel, we are deliberately trading our boundless human freedom for strict, uncompromising mathematical certainty.
Section 3, mechanics of PTY pipelines.
So, how do we actually pull this off? How do we bypass the visual bloat mechanically so we can control modern AI without it just failing on us? Enter the PTY, or pseudo-terminal. A PTY acts as an isolated, completely secure user channel right on the operating system. Because it entirely skips the visual layer, it gives AI agents an environment where they can operate using a 100% exact text pipeline. It's like a direct, lossless wire straight into the machine's brain, generating perfect text logs for every single action. No guessing, just exactness.
But to make this pipeline truly unbreakable, we use an absolute secret weapon. GNAU Screen. GNAU Screen is this back-end tool that creates these isolated TTY channels. And its real superpower? It lets you detach from an active session, let it run persistently in the background, and seamlessly reattach later. It's literally shielding your exact text pipeline from the extreme volatility of modern network drops.
So here's where the magic actually happens in practice. First, you launch an isolated TTY channel. Second, you input natural text, literally at the speed of thought. Third, and I absolutely love this part, you can detach the session, slam your laptop shut, and just walk away. The AI agent's context loop just keeps running safely in the background. Step 4, you reattach days later, and you haven't lost a single character. Zero data loss. I mean, just imagine the peace of mind compared to the sheer panic of your web browser crashing right in the middle of a huge task.
Section 4, the historical text stream.
Now, this guarantee of zero data loss isn't actually new. It goes back decades.
Early engineers figured out this brilliant asynchronous start-stop synchronization. Think of it like a mechanical start signal being sent down the wire just to wake the receiver up, followed by the exact data bits, and then ending with a stop signal to close it out. This incredibly robust mechanical logic guaranteed the exact character-by-character transmission of the text stream across huge distances. And the best part? It did it without needing a shared, perfectly synchronized clock.
And this text stream was also incredibly flexible. Early text signals could actually be instantly converted from hardwired DC electrical impulses into shifting audio tones for radio transmission, a process known as frequency shift keying, and then decoded back into perfectly accurate text on the receiving end. It just proves the incredible foundational resilience of the underlying text stream over literally any medium.
And unlike those fragile modern web protocols that will just silently drop your data into the void without telling you, early text streams were physically secure. They used closed 20 milliamp current loops that acted like physical tripwires. This provided continuous structural diagnostic security. Basically, if the physical line broke, the current immediately dropped to zero, and it would physically alert the operator by making the machine's motor race. It meant we were always anchored in pure, verifiable, deterministic fidelity.
Section 5. Sovereign AI Swarm Orchestration.
So, when modern AI models are just left to their own devices in graphical environments, they tend to generate what we call a probabilistic miasma. It's this foggy, super unreliable state of hallucinating guesswork where concepts just kind of bleed into one another. But the alternative to that is the sovereign pilot. By demanding deterministic execution through the command line interface, a human pilot achieves bit-perfect orientation. You're asserting complete stewardship over the machine using exact, undeniable text logs.
In a sovereign workflow, you're orchestrating highly specialized AI agent identities locally. You enforce a strict LIFO, last in, first out architecture to keep the state super clean. You force those messy, continuous AI vector embeddings to compress down into discrete ASCII text. And most importantly, you apply the sweat of the brow. That's the physical, manual pruning of the code by the human pilot, who is acting as the ultimate steward over whatever the machine outputs. And all of this leads us to a rather provocative realization. If an artificial intelligence cannot escape its own continuous associations without a human physically pruning its text, are they really autonomous? Actually, think about that for a second. True agentic action isn't just passively letting some algorithm run. It requires a non-severable bond. It demands that a human pilot directly manipulate the physical text substrate to bend the rigid machine toward a specific intent. Which brings us to our conclusion, and really a final vital question for you to consider. If we blindly rely on the guesswork of graphical interfaces and probabilistic AI, if we abandon our deterministic text interface, who actually controls the physics of the machine? Reclaiming the command line, mastering the PTY channel, and preserving your exact text logs, that is how you take back that power. So, how will you write your own future at the speed of thought? Thanks so much for joining me for this explainer, and definitely keep digging into the command line.